Okay, so that's now going to rough that shape out. Now again, what we might want to do is looking at that, we might want to consider moving the roughing cycle back to take into account this back face here. This will obviously be done with a separate operation perhaps. So we'll just go back into that and just modify the end position to be there. Click OK and run the job. There we are. Now we could define a separate tool for doing the finishing operation, or we could use the same tool. We'll just use the same tool and we'll do a profile turning operation. So we'll choose profile turning, and the easiest thing to do here is just to accept all the defaults and click OK and see what the tool thinks it wants to cut. Now that's doing it okay, except that it's machining down this front face here. Now we've already faced off, so we don't need to do that. So what we need to do is we need to limit the machining to just these faces here. To do that effectively, we need to know which spans the system has numbered these elements as. And to do that, we click on Options, Number Spans. So we can now see that that's span 6. If we go into the Profile Turning box and go to Options, we can say Start at span number 7 because we don't want to include span number 6. So we click on that. Now we run the job. Okay. Now the other thing that you may have noticed on the profile turning operation, we've got the different parameters here about how we approach and run off the job. So for approaching along here, we might just want a parallel approach, and then when it finishes at the end here, we might just want a normal run off, and the size is set here. Face off, rough, and finish. Okay, so that's done the outside as much as we can with that tool. Now we'll concentrate on the inside. So the first thing is to select the tool we want to use. We'll use the boring bar. If we wanted to, we could switch on constant surface speed here. We can also set the spindle direction. So depending on how your tools are mounted will determine whether the spindle is running clockwise or counterclockwise. The surface speed here is in meters a minute, so that's probably going to be around about 250 meters a minute. I'm not sure what the equivalent is in feet per minute, but it'll be a value which you're obviously aware of. The actual feed rate you're using can be expressed as feed per minute or as feed per rev. And if you want the coolant to be switched on, tick this box here. So that invokes a tool change, so the tool goes back to its tool change position, changes tool, and now we can machine the bore. So we don't have a separate command for boring, but what we use is the turning and facing commands. But if a boring bar has been selected, then the cycles option here has the radio button internal selected. So now we need to use exactly the same routine as we did for outside turning, the cycle limit. So again, I can type in the values here, but it's much easier to select the position with the cursor. So that's the first point, and the second point again is the opposite corner of an enclosing rectangle, which will determine the maximum and minimum sizes. So that's got that. We might want a finishing allowance again on there, and we click OK, and here comes the boring bar and roughs that shape out. Now we could do a similar thing with profile turning, and again leave all the defaults as they are for the time being and see what it wants to cut. And again, you can see how it included that front face in the machining operation. Now we don't want it to do that, so we simply go back and edit that command, and this time we'll end at span number 5, which is this one here. Okay, now if we don't want to see all of the program operations so far, we can simply uncheck them here, and we can only run the tool that we're interested in. Okay. Now, before we do anything else, the tool has finished there. So if this was the final operation on this job for the front face, then we'd obviously need to move the tool back. So to do that, we use the go to command here. You can use this command to drive the tool manually, either in feed rate or rapid, to any position that you want to. So if you have just a single indent to make with a button tool, for instance, you can just drive it to the positions that you want using a series of go-to commands. But we want to send the tool to the home position, but when that happens, we want to make sure that it moves in the Z-axis first, so it comes out of the job before it moves in X. Right, so if we're happy with that, we switch everything back on and then we post-process. Choose the post-processor that you want, and whenever you post-process, it will run the job completely from start to finish. Now obviously, to complete this job we would need to go back into the CAD and mirror the geometry such that the back face here was at the front, and then we could create another program for the opposite side of the job. Okay, that's it.